Yeah, that's where I'm largely focused. I just want to introduce something that will help gather interest, and people
Yeah.
can take it from there because there's an enormous amount of creativity and innovation amongst crowds of people. And so, if you just get the idea out there, someone will figure out how to take it beyond where I've taken it. So Cyan is something that I started developing November of last year. It was about 3 months ago. It's basically, there's one behind me right now. It just takes through air and carbonates calcium hydroxide. So the airflow is aided by a fan, and there's humidity that's being generated in this inner chamber. The humidity together with the airflow allows carbon dioxide to to gather around the calcium hydroxide and form calcium carbonate. So it's a solid method of actually capturing carbon. Now, if you leave calcium hydroxide out, just over time, it will naturally carbonate. This process
Mm.
occurs in cement over long periods of time. That's what eventually leads to the failure of concrete. There's concrete with rebar on the inside. Over time, the concrete carbonates, and that lowers its pH and allows the rebar to corrode. So what I'm doing is I'm speeding up the natural process. I'd like to speed it up even more, but right now it's about a day. I can get 2.1 grams of carbon capture for every 10 grams of input material that I add. So it's a fairly good process. It's something that I'd like to scale it up even greater to a kilogram a day. I'm still working on that process. I
Mm.
have a plan, and I need to build some slats in the middle to allow the surface area to be great enough for this to occur. So, do you have a
Okay.
question? Yes.
Yeah, sure. So
Yeah.
you said it's calcium hydroxide and you're turning it into calcium carbonate. Is that the end? So how do you get the calcium hydroxide, I guess is the
Yeah, that is the big question. So now you can get it as a hydrated lime, which is available from any Home Depot or Lowe's construction hardware store. You can also get it at Ace Hardware. You can buy it as pickling lime, which is even more pure, which is offered in food, like in Walmart and such,
Mm.
canning.
Mm.
These sources are made with limestone. They take limestone, they calcine it at really high temperatures, and that produces CO2. So at most, we're being carbon neutral with the sources of lime that we're purchasing right now. If we wanted to go carbon negative, which is everyone's goal, we're going to need to find a source of calcium hydroxide, which is carbon, which has not been produced from limestone.
Mm.
Ideally, it might come from waste cement. So we're looking at taking this waste cement and actually following, there's a method out of UCLA which actually produces calcium hydroxide without any calcination. They
Hmm.
use a reverse osmosis method. So we were brainstorming the other day trying to figure out a way of doing this. And turns out the paper is relatively simple to follow. It's just the implementation that's going to be a bit rough. Some of the elements are currently expensive, but we'll see if we can lower the price a bit and get something going that will actually produce a low carbon stream of calcium hydroxide.
Yeah. Yeah, and that would definitely get at that sort of that the sort of material that you need.
Yeah.
So I guess another question then would be once you've carbonated calcium hydroxide,
Mhm.
you can no longer use it to capture CO2. Is that
Right.
correct?
Right. It's
So
already calcium carbonate.
so how do you refresh the material? Do you have to fully replace the internal parts of the material once it's fully essentially carbonated
Mhm.
with new sources of okay.
Yeah. So right now it's a one pass process. If you want to regenerate the calcium hydroxide, you would have to go through this process by which you're running it through the uh, most people would calcine it, but we would just run it through the process where Grafstadt's method. He's the professor out of UCLA who developed this method of non-calcination,
Okay.
basically using reverse osmosis. That method might be something we would look at doing to regenerate, but of course you have to put the CO2 somewhere. And in I wanted to make something for home use that I could actually be able to facilitate the production of at home. And having high sources of pressure is probably not a good thing unless you're familiar with like an air compressor and such, and you can use that. So I wanted to keep the costs low. This unit is actually under $100 for everything you see on here. And the core of it is actually $20. I use a recycled hummus container for my innermost chamber, where it actually you can put the coffee filter on top of that, and then let the humidifier humidify the calcium hydroxide from there. So
interesting. So how long does the process take, I guess? How often do you have to swap out your calcium hydroxide that is now turned into calcium carbonate? And what are you doing with the calcium carbonate once you've captured the CO2?
Yeah, at least once a day. I try to do 24-hour cycles so that I'm able to let this run during the night. I wake up in the morning, it's ready to dry, and I'm drying it so I can actually quantify the CO2 uptake by weighing it. So
okay.
That's not necessarily a necessary step, and it will, if you let it sit for several days, it will fully carbonize. It will carbonate, and it will be able to form calcium carbonate.
So you have that's a rudimentary method of CO2 uptake, right? You measure your hummus container with Ca, like hydroxide, and then afterwards you'll measure it with essentially whatever is additional will be CO2 that you've captured.
Yes, I'm actually using coffee filters. So I have these little coffee filters laying around that are just that have material in them.
Okay.
And so I worked with Jennifer Mills, who is a geochemist, and she checked my numbers, and I had Zhao Wu of OpenAir also check them, and we have a standard method that actually the University of Michigan's GCI-UA club has derived this method quite extensively, and it's just basically a basic method of finding out how much CO2 you have captured by the quantity of calcium hydroxide you start with and the weight of the material after, assuming all the water has been driven off.
Okay. Yeah, very, very interesting. Calcium hydroxide will do that reaction naturally, right? So without the sort of, you're using what is it, like a cooling fan or something that you have in that? And that's
this is for airflow to make the CO2 go in, because if you're going to lower the CO2 concentration inside quite a bit. And so I had calculated that in order to get a certain quantity of CO2 capture, I needed like something on the rate of computer fans airflow. So about 31 CFM or something minimum that would be needed. So I started from there, I built the fan in, and then I actually had other tests that I performed with this unit beforehand. So I settled on the calcium hydroxide carbonation process as something later stage. I actually did that in December. So, and then January was when I was running all of my tests. And we started getting interest from OpenAir. So I figured that would be a time to make it more public. And I'm in the process of open sourcing this particular hardware system. It needs no mention. It's so simple. It's dirt simple that it almost does not need to be like anyone can build it, basically.
Right. So you said there's also sort of a humidity component there. So you're
Yes.
putting water in. Are you heating the water to
No,
like evaporate it, or is it just
no.
naturally? So
Natural humidity. I'm using an air stone to bubble up the water, and
Okay.
so that creates inside a mostly closed container. There's also an air pump that goes to an air stone that is in this mostly closed container with the hose
Hmm.
container on the underside, and it allows the humidity to kind of circulate in there, and it's
Okay.
just you need to maintain a relative humidity between 25 and 75%.
Okay.
Higher the better for rapid carbonation of the
Okay.
material.
So do you have like a hygrometer to tell you what the humidity is on the inside
Um,
of that?
when it starts condensing, I figure it's high enough. So
Seems that makes sense. Yeah. You said you tried other. Did you try other things before you did calcium hydroxide? Are there
yeah,
other sources? Okay.
yeah, and then
What
there.
were those?
Well, I looked at sodium hydroxide, but I thought that wouldn't be very good for home use because of the corrosivity of the sodium hydroxide. Calcium hydroxide is, it's a pH of 11 or 12 by the time if you start with pure stuff. But
Mm,
I found that I didn't have to wear gloves or anything with it. It was pretty safe for use. I didn't notice any. I had a mask when I started, but then I was very careful not to let stuff go into the air. I just scooped it and
mm.
then dropped it in.
Yeah.
So this technique is more amenable to home use, I think,
Yeah.
and to students experimenting than
Yeah.
using
Definitely.
outside.
Yeah. I think especially nowadays, though, I mean, a mask would be pretty common pretty common
Yeah,
household device to have. So you wouldn't even be
very,
asking that much for someone to have a mask. But
very.
I mean, that's good. That's good that it's a safe process that's easy
Mhm.
for people to use.
Yeah, and you
Um,
mentioned the calcium carbonate. What is done after the fact? I didn't
yeah.
answer that question yet.
Oh,
So
right. Yeah. Yeah.
yeah, so I basically I have it sit around and then for about 10 days, and I measure the weight increase after 1 day and then at 10 days
Okay.
to see if there's any kind of lingering humidification that occurs. Now,
Hmm.
my room is at about 10 degrees relative humidity, or 10, not 10 degrees, 10 units of 10% relative humidity,
Okay.
10 at most 15. So it never gets to the 25% where there will be carbonation occurring
Okay.
from the. So I let it sit, and there's still water in the material. It's not fully dried yet at the end of 1 day.
Hmm.
So at the end of 10 days, it's probably all done within 2 or 3 days. I haven't checked that short time frame.
Hmm.
Brian Anderson has told me that it's done within like 2 or 3 days.
Okay.
So it's pretty quick of a process. When I let it sit for 10 days, I'm convinced that it's then very dry. Uh, I then weigh it again and then get my final numbers for carbonation. So after that, I then have a choice. I can put it out in my garden, or I can use it for other materials. And I've been saving it up because it could go into building materials.
Hmm.
Like, for example, cement can be transformed into cement lime. The calcium carbonate can actually go into cement, and then I can build something with it. Like
Okay.
if I wanted to make a cover for my well, or out here I can do a lot of things. It might not be that amenable for city use, but
Hmm.
there are some things you can actually pick up the calcium carbonate, send it to your recycling concrete place where they
Hmm.
recycle concrete as well, because it is essentially concrete material.
Right.
That's just carbonated over time.
So I know there's a big opportunity within the concrete industry, which is to break down concrete and that it'll naturally, because there's, I guess, calcium hydroxide in the concrete, it'll
Yes,
naturally continue to absorb CO2, especially parts that before weren't exposed to air. If you kind of break
yeah,
it open, it seems like
I've
you'd have that. So Is there any, I mean, you're talking about regeneration, you're trying to find new sources. Is there a industrial byproduct that could serve as the product to begin your process in cyan?
Yeah.
Like, could you use
Waste
that?
cement.
Okay,
Yeah,
waste cement would
cement
be.
could actually do it. It is calcium oxide that has been slaked by adding water to the cement. I mean, basically, effectively, that's what it produces is calcium hydroxide.
Okay.
So the cement, when it's dry, is calcium hydroxide. It's mostly calcium hydroxide. There's going to be some other things in it like magnesium hydroxide and other things that also take up CO2 during the long term.
Okay.
Now, there is the difference between cement and concrete are the aggregates. You don't want to use recycled concrete because you'll end up with having such a large amount of material.
Yeah, like 75% will be like sand and gravel and stuff, right?
Yeah. So waste cement is what we're looking at obtaining. Okay. And there's the process of grinding it down, which I know that with concrete, these concrete recyclers can do it very easily. They can get it from 3/8 of an inch down to powder with their units. So if they can do the same for cement, we would have a solution. Okay.
Wonderful. Yeah, that's really good to hear. So I think, at this point, right, you have this sort of device. How much CO2 has this device, have you added up how much it's captured sort of throughout its lifetime? Do you have a value for that right now?
Yeah, it's under 40 grams. I think I'm definitely getting above 40 grams soon, but it's I think I'm at 37 or 38, I forget. I'll have to check, but it's under 40 currently.
Okay.
And it is something that the calcium carbonate, just because I'm doing everything in my one office, I've been very careful to measure how much I've actually done. It is a small scale unit. It's not going to meet Elon Musk's requirement of a ton a day, but it is a very useful unit for getting people started with the idea of direct air carbon capture, and that it's possible. Yeah. And it's so easy to modify this unit to be able to consider other things. Like I was working with table sugar earlier. Table sugar apparently increases the amount of calcium hydroxide in solution. It is able to complex with the calcium hydroxide. And I didn't notice any significant increase in weight, but that was because I was assuming there was no reaction with the calcium hydroxide and the table sugar. So apparently there is some reaction. It becomes calcium saccharate, I believe. So I don't know how to figure that in. A chemical engineer would know what to do with that. So I leave it up to the University of Michigan folks to solve that one.
It seems like there's a lot of chemical engineers interested in the project. So
yes. And this is something that I've been working on, just the physical aspect. Basically, it's CO2 mineralization at a rapid scale using direct air carbon capture, and that's what we're essentially doing with the Cyan unit. So we're combining two avenues of this, and it's very permanent storage of the calcium carbonate. Unless you have acid rain raining down on it every day, it's going to be very, very solid storage for
right. From a chemical energy standpoint, the carbonate is a lower energy level than CO2. Is that right? So it's like a beneficial reaction for CO2. Is that?
It is lower energy, meaning that it doesn't take energy to form CaCO2.
Okay.
Yeah. So calcium carbonate is it's a downhill reaction. Once carbonation starts, it all runs downhill. So.
All right. So it's not like we're putting a bunch of energy into turning CO2 into something else. You just have to.
It's a natural process. And the energy that I use is for the fan and for the air pump. So the fan uses about 3 watts. The air pump uses 1.5 watts at the moment. So that's 4.5 watts of electricity that I could, if I just let it naturally dry, it's just 1.5 watts, but I
Okay.
choose to dry it faster so I can get it done within a day.
Okay.
And there's also, in order to scale it up to 1 kilogram a day, I need to fill this entire container full of stacks of calcium hydroxide. Once I do that, I'll need to humidify the entire container, which I'm only doing a small section of it now with the hummus container in it.
Mm-hmm.
I need to humidify the whole thing. And to do that would probably take, I need to use my sonicator to do that. It's an ultrasonic fogger that actually produces a lot of fog.
Okay.
And that is unfortunately a 24 watt unit.
Okay.
But I want to try it out and see
Mm.
what it does and whether or not it's going to allow me to do a kilogram a day. So
Yeah. I mean, if you could scale it, right, that would be the greatest thing. At some point, you can use the 24 watts, but you can be doing a lot more sort of carbonation with that. Okay.
Yeah. Mm-hmm. So that's something that maybe the undergraduate association at GCI can try out some of these things as well.
Yeah, because it seems like you have a pretty like a modular, because you have this sort of internal, the box, and then the big box on the outside, and then these sort of smaller boxes within. So
Yes.
you can sort of create that several times over within the
Yeah.
big box and try to make that work. Yeah,
Yeah.
I mean, I think that's the hope, right? Is that we can set this up and people will run wild with it. Because even I'm just looking at it, it's like, okay, it makes sense, and it's sort of it's intuitive in some way, which I would say maybe direct air capture is not always an intuitive thing for people. So
Yeah, and especially because direct air capture is so large scale, unless you know like the layout of your plant and what's actually happening, it's not something that a person who's just getting started on direct air capture, they will be able to open the lid and see what's going on and have a more an intuitive understanding what's going on that you can't have on a large scale system. So I think it'll bring more people into the field and galvanize interest around supporting direct air capture.
yeah, I guess I mean, you're just good at sort of room temperature for these for the device.
Yes, I'm doing room temperature, standard temperature, and pressure pretty much. It's not I'm not using any pressure in this system. I haven't heated up anything. So if you were to heat up the calcium hydroxide, you can get a much faster reaction.
Okay.
But of course, you're taking energy and having to feed it into the system. If you were to derive energy from concentrated solar, that might be a good way of doing it. But of course, that's only available half the day unless you have thermal storage somewhere.
Yeah, I feel like this helps me sort of get a better understanding of the device, and hopefully I can sort of, I guess one last thing is sort of more philosophical, but what are your hopes for Cyan, and where do you see Cyan and these types of devices, specifically, direct air capture in carbonating materials, that is something that we've been hearing, or at least I've been hearing about in the CCU space. But I think it's really interesting to have these sort of devices. So I'd love to hear sort of what your perspective is on where that's headed and where you want it to, what direction you'd like it to go.
Yeah, it's like my take on Cyan is like getting people involved at an early stage, capture their interests, and then they might pursue means of doing more in direct air carbon capture. I see this as an opportunity for innovation, bringing more people together who otherwise would not be brought together, and having something that you can play with and see if you can get like the largest amount of CO2 capture of depending on what modifications you make to it. And then from there, you can get, if once you're interested, you can start looking at other units. But yeah, Cyan is going to be something that hopefully gets people interested in the field. Yeah, that's where I'm largely focused. I just want to introduce something that will help gather interest, and
Yeah.
people can take it from there, because there's an enormous amount of creativity and innovation amongst crowds of people. And so if you just get the idea out there, someone will figure out how to take it beyond where I've taken it. So.